Hello friends, in this video we are going to see design of singly reinforced beam in working stress method. Question is, design a singly reinforced concrete beam of a rectangular section is simply supported on masonry wall 300 mm thick with an effective span of 5 meter to support a service load 8 kN per meter and a dead load 4 kN per meter in addition of its own weight. FE415 width of support beam is 300 mm. Now we'll see the given. Here wall support is 300 mm. Effective span is 5 meter. Live load is 8 kN per meter. Dead load is 4 kN per meter. Fy is 415. Next step is design constant. This is for calculating effective depth. For effective depth, we require Q formula. So for calculating Q formula, we need M, N and J values. So the formula of M is 280 by 3 into sigma CBC and N formula is M into sigma CBC by M into sigma CBC plus sigma ST. J equal to 1 minus N by 3 and the Q formula is 0.5 sigma CBC into N into J. So the sigma CBC value is in IS456 page number 81 and sigma ST value is in IS456 page number 82. Referring to this, the answer is M equal to 13, N equal to 0.283 and J equal to 0.905, Q equal to 0.890. Next is dimensions. Dimension formula is depth provided equal to effective span by 10. Effective span is given in the question 5 meter. So if we calculate this, we get 500 mm and the overall depth formula is depth provided plus clear cover. For beam, the clear cover is 50. So the answer is 550 mm. Next step is load calculation. So first we must find self weight equal to breadth into overall depth into RC. Dead load is given in the question and live load is given in the question. So the answer is 16.125. Only slab has floor finish, not for beam. So in beam load calculation, floor finish will not be there. And for singly reinforced beam, depth provided formula is L by 10 and for doubly reinforced beam, depth provided formula is L by 20. This is a small note. Next step is bending moment and shear force. Bending moment formula is WL square by 8 and shear force formula is WL by 4. W value is 16.125 and L is given in the question. So the answer of bending moment is 50.39 and shear force answer is 40.31 kilonewton. Next step is check for depth. So the formula for check for depth is depth required equal to M by Q into B, root of M by Q into B. M value is bending moment answer 50.39. Q value is taken from design constant and B is breadth. So the answer is 434.4 mm. So depth required is less than depth provided. So the depth provided answer is 500 mm. Hence, the design is safe. Next step is tension reinforcement. M equal to sigma st into ast into j into d. M is bending moment equal to sigma st into ast into j value is design constant and d is depth provided. So the answer of ast is 484.17 mm square. Now we must find number of bars in tension reinforcement. So the formula is ast by small ast. Small ast formula is pi d square by 4. D is 14 mm dia. So the answer of small ast is 153.9. So ast by small ast equal to 3.14. So we provide 3 bars. Provide 3 number of 14 mm dia bars as tension reinforcement and 2 number of 10 mm dia bars as hanger bars. Next step is check for shear stress. This is used to find tau v and tau c values. If tau v is smaller than tau c, the design is safe. Tau v formula is V by B into D. V is shear force and B is breadth and D is depth provided. The answer is 0.268. Next, K into tau c. K value is in IS456 page number 84. Now percentage formula is 100 into AST into BD. This is calculated for finding tau c from the table. So the percentage answer is 0.3. So nearest value 0.5 we take. So percentage value is 0.5. Now we must refer IS456 page number 84. From the table, using percentage value, we must find tau c value. So the tau c value is 0.3 Newton per mm square. So tau v is lesser than tau c. Tau v value is 0.268 and tau c value is 0.3. So the design is safe. Now we must find spacing. Spacing formula is 0.87 fy into ASC in by 0.4 into B. This formula is in IS456 page number 48. ASV formula is pi d square by 4. Dia is 8 mm. So ASV answer is 50.26. We must assume the dia for ASV. Now we calculate this answer in spacing formula. So we get 150 mm spacing. Next, the above found answer is written here, presented as reinforcement details. We found overall depth equal to 550 mm. Depth provided is 500 mm. Effective span is 5000. Support which is 300 mm. And main reinforcement provided is 14 mm dia bars at spacing 150 mm center to center. Distributed reinforcement, we provided 8 mm dia bars at spacing 150 mm center to center. This is singly reinforced beam diagram Overall depth is 550 mm and depth provided is 500 mm, and tension reinforcement, bottom 3 bars are tension reinforcement, 14 mm dia bars at spacing 150 mm center to center, breadth is 300 mm, and top 2 bars are called hanger bars. So this is the diagram for singly reinforced beam. Thank you.